Okay, hello everyone. Welcome to this video lecture of History Department. The topic I'm going to deal with today is the quantitative techniques in historical research. For those of you who don't know me yet, I am Dr. Youngook Jang, a postdoc fellow in LEAP and Biography of an Uncharted People project. I am keen to answer any questions as to the lecture today, but unfortunately it's not going to be possible person to person. So I'm happy to take your questions by email written here. Okay, so these are the contents of today's lecture. And then, if I express the aim of this lecture in one phrase, then it would be this: demystifying numbers. Last year, I did the same lecture in front of a bunch of historians who were saying that they didn't feel comfortable using quantitative skills in their research. After the lecture that I gave, I got a valuable feedback from some of them that I demystified the mysterious number crunching. So it's 1.5 hour lecture, and I can't cover all the important concepts and skills in detail here today, but I will try to introduce most useful things that you would want to remember for the future research so that you can use Google and YouTube to search them later. Those concepts would help you understand quantitatively oriented research papers as well, which I think are important in understanding history more comprehensively. Okay, all right. All right, so in order to demystify quantitative techniques, I will take the following steps. First, you've got to know why you need numbers before you learn how to use them, right? History as a social science usually takes scientific research methods, which I will explain in a slide, okay? And then I will explore the concepts and usage of some quantitative methods, like how to use numbers in history research, how to understand the quantitative research, and some common mistakes that you may want to avoid, okay? Then lastly, I will very briefly touch on the GIS techniques. It's increasingly popular to incorporate geographic information into historical research. So I'm going to show you some examples. Right, then scientific research. So I'm going to explain 5 steps to make your research scientific. So this is the usual steps that the scientists in natural science takes, right? So the first step is research question. To have a good research question is very important in scientific research. So the example would be the effect of chili. So the question is chili good for the prevention of cancer? So that's the research question you want to prove. And then the next steps can rely on this question. So if you have good research question, then you can proceed to the next step, which is observation. So now you observe the people who eat a lot of chilies and who don't eat chili at all, and then see if these two groups have different tendency to get cancer or not. So that's the observation. And usually this the step of observation is interactive with the step of research question. So if you have good research question, then you'd be able to find what to observe. And if you have good observation, if you have, if you do some observations right, then you would be able to draw a good research question out of this observation. Okay, so these two are interactive. And the third step, if you have right research question and then if you do if you did some observation, then you can make a hypothesis. So out of observation, if you observe that eating chili was good for the prevention of cancer, then you can hypothesize that. So eating chili is good for the prevention of cancer is one hypothesis that you would want to prove in your scientific research, right? Of course, this hypothesis is interactive with the observation and the research question, right? And the fourth step, so if you have the hypothesis, then you can do experimentation to prove if the hypothesis holds or not, right? So in experimentation, especially in natural science, you have this control group and treatment group. So control group and treatment group are exactly the same, except one thing: chili. So you have this, you have people who have the same age and same health, who are having same health conditions, and like every other thing is same, but one group, the control group, don't have chili, and the treatment group have chili, right? So this is experimentation. You control every other environment except one thing that you want to test, right? That's experimentation. And then the last step is conclusion. So if you find a significant reduction in the rate of cancer in treatment group, then you can conclude that chili is good for the prevention of cancer, right? If not, you can't reach the conclusion. So these are the 5 essential steps that you need to take in scientific research. So most of the research papers in natural science have these 5 steps, right? And these steps must based on literature review, especially the first to fourth steps should be relying on other scholars and other papers that have previously, studied the same topic that you are interested in, right? So you can use Google Scholar to search for the previous literature, previous papers, right? And then if you have read a lot of papers on your topic, then you'd be able to have a good research question, and you can do some good observation, and also you can make good hypothesis. Also, you would be able to find the best way to test your hypothesis from the previous literature. Okay. So those were the steps that the natural scientists take. Natural scientists are the real scientists, I would call, right? So like Sheldon Cooper and Amy Farrah Fowler from Big Bang Theory, the soap opera, American soap opera, if you like it. But in social science, it's impossible. It's impossible to have the control group and treatment group in a laboratory, right? It's not possible. So you need to rely on the existing data, like existing quantitative data. And if you analyze the quantitative data, then the research method is quantitative. If you conduct survey or interview on your own and analyze them, then it's going to be qualitative. Or you can just explore the historical documents and and collect data on your own. Then it could be another way to do research, right? So I'm going to focus on quantitative research today, right? And in quantitative research, the first thing that you would need to have a look is descriptive statistics. So descriptive statistics is basically the summary of data. And you can get the summary of data by arranging and displaying the raw data, right? So the first thing that you have to summarize is the distribution of a single variable. It's just common average, mean, median, and mode, and also distribution like variance, standard deviation, and minimum and maximum and skewness or something like that. I'm going to explain it later in detail. And also you usually categorize and compare 2 or more variables, not only see distribution of a single variable, right? And then you can use tables, graphs, and charts to show the characteristics of the variables that you have. And these are all descriptive statistics. So descriptive statistics are good for observation in the first place, and then you'd be able to use these statistics to to prove your hypothesis in experimentation step. So I usually explain these key skills from beginning to end, and that's what I did when I did this same lectures at the LSE when I did PhD. And it's usually take 2 hours a week and whole semester. So it's like 20-hour thing. But it's impossible to explain everything in this 1.5 hour lecture. So I'm not going to do that. That's going to be not effective, and that's going to be very boring, right? I think you are a little bored. So I'm going to apply the key concepts and apply the scientific research steps in a real research question that you would be interested in. And the research question I brought today is this: how can I get more likes in Instagram? I don't know how many of you have this Instagram accounts, but I have it, and I was interested in the number of likes that I get, and I was curious what kind of postings and what timing of postings and what frequency of those postings would get me more likes, right? I mean, it's obvious that if you're good looking and if you're very outgoing and if you have good camera or something, or if you have good skills of photographing, then you get more likes, right? That's for sure. But I don't have any of these, and still I can answer this question because the most important premise of all research is this ceteris paribus or ceteris paribus, other things being equal. So if I don't change anything else, like my appearances or my camera or my personality, what kind of variables would affect the number of likes? That's the question, right? So I just ignore something that I can't change. It's fine because they are all equal. And I focus on something that I can change, something that is variable, right? So given that I have the same appearance and same camera and same personality, what would affect the number of likes? That's the question I'm going to explain. I'm going to test today, right? So yep. So this is my account. It's basically babystagram. So I usually post the photos of my babies. My baby, my one baby. Right. So since you have a research question, whether it's good or bad, you can now do observation. And you can do observation by collecting data. But before you collect data, you have to decide which data you want to collect. Then here comes the good questions again. So if you have a good guess about the things that might affect the number of likes you have, then you'd be able to collect your data more effectively. So let's pause a bit and think about the variables that might affect the number of likes you get. So I'll give you one or 2 minutes to think about this. Okay. Yeah, but I don't think I have to give you time. You can just pause and think, and I'm going to continue. All right. So I thought the timing of postings is important. So if you post it day or night, weekday or weekend, so initial likes that you get is very important to make your postings exposable longer. So if you post your photos in early morning or very late night, then your postings might not be exposed as long as the postings that you post in daytime or something like that, right? So timing of posting might be important, and type of postings also might be important, like if it's photo or video, and type of photos, whether it has some people there or it has just landscape, selfies, family, like baby or something like that, or a cat or something would be important, right? And then the number of people in photos. So if you have more people in your photos, then those people would give you likes, right? So the number of people is important. Also, the number of people that were tagged, that is tagged in your photo, may be another important factor. So the number or type of hashtags. If you have more hashtags like me and I like you back or something like that, like for like or something like that, right? Or professional likers or something, may affect the number of hashtags, number of likes that you get on specific posting, right? And the frequency of postings also is important, right? If you post too many postings in an hour or something, then the posting that you post later would get less likes or fewer likes. And special events, so if you have graduation ceremony, or if you have birthday, or if you have baby or something, then you'd get more likes on that photos, right? And subjective evaluation, the evaluation on the photos your evaluation on the photos that you post might be another important thing. So you think one photo is very good or the others are not, then the good photos might get more likes. And the last thing I thought is the likes on others posting, the likes that you give to others postings. So if you click more likes on others postings, then they would click likes for you. So we've looked at the factors which might affect the number of likes that I get, right? And then I had to enter all the characteristics of my postings here, like the timing and the day, year, whether it's weekday or or weekend, whether it has how many people and the type of postings and everything. I entered everything here. And now we have several variables that we can observe, and we have to decide which characteristics these variables have. And we do that by looking at the distribution of these variables, right? So this distribution is determined by two factors. First, the measures of central tendency, mean, median, mode, average, right? And the second is the measures of dispersion. So having these two at the same time is very, very important. Even if you have two different variables that have different mean, different average, you can't say that these two are different definitely if these two have very dispersed distribution. So the central tendency is important, and the measure of dispersion is also important, right? All right, so to measure the central tendency, we usually use mean, the sum of values divided by the number of observations, right? That is easy, right? And median is the middle value when you arrange all the values of single variable in order, right? So mean and median might be different if the variable has skewed distribution. I will talk about it later. And we have several measures of dispersion as well. The range, the difference between maximum and minimum value, and then variance, the average of distance from mean squared. So this is the measure which gauge how far individual value is from the mean. Okay, and standard variation is square root of variance, and skewness here. Skewness is lack of symmetry. Here, the skewness. So if your variable has distribution skewed to the right, that means that it has outlier at the right hand side. So if you have outlier, one big value in one variable, then your mean should be larger than median, right? So median is independent of outlier, whereas mean is kind of dependent on outlier. So if you have a big outlier in your variable, then median is better measure of center tendency than mean, right? So if you have outlier to the left hand side, then it's skewed to the left. I will show you some examples of these, so don't worry if you don't understand it at the moment, okay? Okay, so this is the summary statistics, so descriptive statistics of the number of likes, okay? So number of likes is the variable, and each like, the likes that I get from each posting is the value, okay? So you have several values in one variable, and the variable likes have some values that have center tendency of these and center and dispersion of these. Okay, so the average number of likes that I get is 44.5. Okay, and median is 42, and max I got 90 likes in one posting, and I got 23 likes in one posting. Okay. So range, which is the difference between max and mean, is 67, and the variance is 147, and standard deviation is 12. So this is the histogram. So I have several intervals, like of the number of likes. So from 23 to 33, I got 10 postings. From 33 to 43, I've got like 22 postings or something like that, okay? So when you draw this histogram, you have to set the median value at the center and see the distribution. So if you look at the far right interval is from 83 to 93, which is the maximum, the posting that I got maximum likes, has just one frequency, just one, right? And this is the outlier. So the distribution of the likes variable has the skewedness to the right, right? So this is important when you interpret or design experimentation and the results of the experimentation, okay? All right, so now I'm gonna talk about which form is the best when you present your data. So usually we use a table or graph. So tables and graphs at the same time should have a title that briefly describes the contents and also the time period and units used, right? So, and especially in graphs, you should have axes and curves that are labeled. Okay, so labeling is very important. Okay, and all tables and explanations must have source and explanatory data note. So you have to have note that is explaining the source and something that is missing from the table and graphs themselves. Okay. And in table, you have to have column and row headings, and they should be self-explanatory, right? And something like percentage and logarithm, that is called derived statistics, and these statistics need to be close to the original data and be self-explanatory. So this is just several principles that you have to remember. It's just take note and think about this when you have tables and graphs in your dissertation or something like that, okay? Sometimes you have to use tables and sometimes you have to use graphs. And it's best to use tables if your display should be used to look up individual values. So graph is visually better, but it doesn't have specific values. It doesn't show specific values of specific variables. So tables are useful when you have to look up individual values. And it will be used to compare individual values, but not entire series of values to one another, right? So, and then the precise values, if the precise values are required, then the table is the best. And the quantitative information to be communicated involves more than one unit of measure. So if you have different units of different measures, then tables are the best. Graphs usually compare within one unit. If you have two different units, then it's hard to express it in graphs. And yes, it's the same. So I'll show you several tables. Okay, that's easier, I guess. Categorization of comparison tables. So you can do categorization and comparison easily in tables. So if you look at the number of likes by subject of photos, I sometimes have my baby in my photos, my wife, myself, or landscape, or hashtags like Babestagram. So I categorized it in this table, one table, right? So if I have baby in the photo, the average number of likes is 43.9, and if I don't have my baby, then it's 47.4. So people might not like my baby in the Instagram photo. That was actually surprising to me when I did this observation. But there must be another reason. But this is something that I observed from the postings that I had. Okay, and if I have my wife, on the other hand, the number of likes increase a lot, right? It's 54.8 if I have my wife in my photos postings. Right? If I don't, it's 41, something like that. So if I have myself, then the number of likes go up, and if I have landscape, then also the number of likes go up. And if I have the hashtags here, I mean conditional on the presence of baby. If I have Babestagram, so the hashtag in my posting, then the number of likes go up. Okay, so it's probably because some strangers, use this hashtag to search search photos with baby, and then they came to see my postings and click likes or something like that. Okay, so these are the way I expressed number of likes in table. So table was useful. Table was effective in express the different values of different variables, right? And sometimes graphs are better, right? So graphs reveal more than a collection of individual values, and it has feature nature, so they show the overall shape of the data. And you should use graphs instead of tables when the message is contained in the shape of the values, right? Patterns, time series trends, or some exceptions. So yeah, exceptions, yeah, or something like that. Okay. So if you, I used the histogram to show you the distribution of the values of my values of the likes, right? And it was very clearly shown that I had, the distribution skewed to the right, and I have the outlier to the right hand side. Okay, something like that. And also the display, when the display will be used to reveal relationships among whole sets of values, graphs are better. Okay, so here are some examples of usage of graphs. Okay, so I expressed the time of postings or the differences in the number of likes by the timing of postings using the graph here, right? The time. But there is a shortage in this graph. So I said you have to have labels on all axes, right? So I have likes, the number of likes in y-axis here, and number of and time on x-axis. So you have to have the label, remember that. And then I see some patterns here, right? So if I post the postings in the morning, then I tend to have more likes, and in the afternoon I tend to have fewer likes. It's probably because people work in the afternoon and they kind of shirk in the morning by just searching Instagram and give likes to others, right? And I have just bit the range of likes in the evening and at night. So this is the pattern that I found from the from the postings that I had in terms of time. And then in terms of day, there is no particular patterns observed here. It's just Thursday and Saturday I got more likes, but I don't think it was very important. So I see some patterns, but it's not very it's not very definite. Okay. Right. And I've got more graphs to show you the number of likes by different characteristics. So in terms of frequency of postings, I've got fewer likes if I post too much or too often. So this is the number, the first graph is the number of postings in past 3 days. So if I post 3 days in a row, then I got like 10 fewer likes than the first posting. Okay, this is what is shown in the first graph. And the second graph, number of hashtags. So it's there's ups and downs, but I think I tend to get more likes if I have more hashtags regardless of the hashtags themselves. Okay, contents of the hashtags. So if I've got more hashtags, then I get more likes. That's what is shown in the second graph. So far I have a research question and I did some observations related to the research question, right? And then from these two, now I should make a hypothesis. So I can have several hypotheses from observation. The first one is the timing of the postings. So the timing of postings is important. I get more likes in the morning. This is first hypothesis. And second, I get fewer likes if I post too often, right? So I have to, adjust the interval of 2 postings if I want to get more likes. Third, baby photos get fewer likes, while the photos of my wife and myself get more likes. So the people who are in the photos are important, especially the baby has negative effect and my wife and myself have positive effect. That's the third hypothesis. And fourth, some hashtags like Babystagram boost the number of likes I get. So I should have more hashtags if I want to get more likes. So these are 4 hypotheses from the observation of the data, right? So now we have hypothesis to test. So it's time to test by experimentation. Okay. So we have observation and we have some conclusion from the observation, but this conclusion is not tested, not proven, right? So you shouldn't draw conclusions from observation directly. The reason for this is that you don't control the groups. You don't have control groups and treatment groups. So this is just observations with all different conditions are mixed. Okay? So in other words, ceteris paribus is not guaranteed. Other things being equal is not guaranteed. Okay? So for example, in terms of timing, so I tend to have more likes in the morning and fewer likes in the afternoon. But it's not because of the time, if it's not because of the timing of the posting, but because of the quality of captions that I have or the number of hashtags that I have in the afternoon, because I was in the office. So I was in the office, so I didn't write the proper captions and I didn't have as many hashtags as I did in the morning or something like that. Then it's not the timing. It's another factor like captions or hashtags, right? So if other things, other conditions are not controlled, then I can't say that it's the timing. It might be another factor, right? Second example, if my wife was included only in the photos on special days, so if I don't post the photos of my wife in normal days, but just in the special day, just on special days, then it's not because of my wife that I got more likes, but because of the events, right? And thirdly, if I posted too many baby photos, it's not because of my it's not because people don't like my baby, but I just posted too much, then too often. I mean, and then it's not the baby, it's not the person that is in the photo, but the frequency of the photos, right? So I had several observations, and I have made several hypotheses from the observation, but we can't say that the factors that factors in the hypothesis were the most important thing that had affected the number of likes. There might be another factor. So, but the problem is that I can't do experiment on this deliberately, right? So I can't, maybe I can. I just can make several postings that have same character, same timing, same number of people, same hashtags, and same day, but with my baby in one group and the other without my baby. So if I did that, if I deliberately make the control group and treatment group and see how many likes that I got, and if there is difference between these two groups, then it's experiment, just as in natural science in laboratory experimentation. But it's not possible. If I did that, then people would just just leave me, just don't leave any likes to my postings, right? So if you want to do it naturally, I mean, if you want to do experimentations having the same effect of control group, you do regression analysis. So regression analysis is used to find the impact of an independent variable x on a dependent variable when you control for other variables. So, I mean, the most basic regression analysis is the linear regression, linear single regression, single variate regression, and we use this equation of a line. But so alpha is intercept, and beta is slope of the line, and epsilon here is the error term, the vertical deviation from the line. So here, most important is beta. Beta is the effect of x on y. So if you increase x by 1 unit, then you would get more of y by beta much, right? So beta is most important. And OLS regression, there are several types of regression, but the most frequently used one is OLS regression, ordinary least squares regression. And this regression fits a line through a set of observations by minimizing the vertical deviations. To be more precise, it tries to minimize the sum of the squares of those deviations. So you have several observations here, stars, and you can draw a line that makes the deviation from the stars the least. So this is example from one of the most famous papers in economic history, which is AJR, Acemoglu, Johnson, and Robinson, about the effect of institutions on long-term economic development. And there are several countries here, and on the y-axis you have log GDP per capita. On the x-axis you have the quality of institutions, the average expropriation risk. This is the level of protection of private property rights. And if you have better, so on the y-axis, if you have better institutions, then you have more economic development. That's the line here means. So if you so for example, on the right hand side you have USA, Canada, New Zealand, Australia, and Singapore, they all have very good protection of private property rights, and this is expressed in these diagram, and the line fits all the different countries included in here. Okay, and OLS regression is just to find this line. And that's single variable model, and then you can include more variables here, and this is called multiple regression. Now you can have x1, x2, x3, and etc., etc. And here beta is the impact of x1 when controlling for x2, x3, and etc. So beta is the impact of x1 ceteris paribus, other things being equal. It's not perfect. There is error term here, and there is different standard deviation and standard error here. But we know that we control for other factors when we get the effect of one variable x1. Okay. R squared is another important term. So as a measure of goodness of fit of the regression line. So R squared is a proportional variation in Y, which is explained by the variation in all x factors taken together. So if you have higher R squared, that means that the variables you have, the x factors you have, explain the variation in Y very much. If you have low R squared, that means that you missed something. So you missed some important variables that is explaining the variation in Y. So it is always better to have higher R squared in OLS regression. Okay, that means that your model explains the variation in the dependent variable very well. Okay. So in order to do the regression analysis, we usually use several different software packages, and I use Theta, and people in our department sometimes use R, and eViews and other software packages can be used. Okay, and I did regression with all the different variables here, having with the number of likes in dependent variable, and I show the results here. So I think you might have seen the tables with these stars and these dependent variable and independent variables and number of observations and R squared, right? Okay, so this is the table table that is usually used to show the results of regression analysis. Okay, so in order to interpret the results, the first thing you need to check is the sign of coefficients. If the sign is positive, that means that the variable has a positive impact. If it's negative, then it means that it has negative impact. So the first thing is the sign of coefficients. And the second thing is the significance level. So the significance of coefficient is something that you have to check in the table, right? So, and usually the significance of the coefficient are in the bracket, okay, below the coefficient. And we usually use t-statistics to determine the importance or significance of the coefficient. If the t-statistics usually in the bracket is higher than 1.645, that it means that it's 10% significant level. And if it's over 2.5, then it's 1% significant. So you need some background to understand the significance level. But before I explain the significance level or the meaning of significance level, we have to learn what hypothesis testing is first. Okay, so we usually test hypothesis with the results of the regression analysis and using especially the coefficient. Okay, so using the coefficients, we want to know if the impact of an explanatory variable is greater than 0 or not. for example, if my wife or having my wife in the posting has positive effect or on number of likes or not. Okay, so this is the hypothesis we want to test using the coefficients. So you might think if the coefficients have a positive sign, it's greater than 0, but it's not always true. So if the distribution or dispersion of the coefficients is very large, then you can't say that it's greater than 0. For example, if it's the coefficient was 0.3, but the standard deviation is 1 or something, then it's in the negative side as well. So if the coefficient is large enough to even after considering the dispersion, then you can say that it's greater than 0. But if it's not, then it's just 0 or close to 0. You can't say that the coefficient, the variable has a definite effect if it's not very far from 0. Okay, that's the hypothesis we want to test. But in the but actually what we test is the null hypothesis instead of the hypothesis that we are interested in. There are several justifications of this, but I'll skip that at the moment. Just remember that we usually test null hypothesis instead of the alternative hypothesis or true hypothesis. Okay, so H0, which indicates the null hypothesis, is that beta is 0. So we are testing if this null hypothesis is true or not using the coefficients. Okay. Okay, so now we want to reject H0 to accept H1. So that means that if we reject H0, we reject the null hypothesis, then we prove our hypothesis. Okay? It's a bit complicated, but in the practical level, it's just nothing. So this is theory that you might or might not want to remember, but this is the principle that is behind the interpretation later. Okay? So there are two types of potential errors if anything goes wrong. So if H0 is false and we reject it, and then it's fine. And if H0 is true and we don't reject it, then it's fine. But if H0 is true and we reject H0, then there's something going wrong, right? So the type 1 error is when H0 is true but we reject H0. That's basically when we claim that we discover something while we actually don't, right? And type 2 error is when here is when H0 is false, but we fail to reject H0. So we don't claim anything when we should have done. Okay, so so think about these two errors and imagine which error is more critical or more fatal. So the type 1 error is something. Type 1 error is there is nothing. There is nothing that we found from. There should have been nothing we found from the regression analysis, but we claim that we found something. Okay. The second type error is we didn't claim anything when we should have done. So if you think about the court situation, the type 1 error is that we or the judges find someone guilty when he or she is innocent. Type 2 error is the jury or judges find someone innocent when he or she is actually guilty. Okay, so which one is more serious? Which one is more serious error? It depends on the value judgment that you have, but we usually think that type 1 error is more serious. So it's alright if you don't find anyone guilty if he or she is actually guilty, but it's going to be a big problem if you find someone guilty when he or she is innocent, right? That's why you apply the rule of not innocent until proven. Not guilty until proven, or the rule of a reasonable doubt. So the proof or evidence beyond reasonable doubt is important in the court, because you shouldn't find someone guilty when he or she is innocent. So type 1 error is more important than type 2 error. If you don't find anything and you don't claim anything, then it's fine. Even if it was actually true, it's fine. But if you claim some forced thing when it's not true, then it's going to be a problem. Okay? So the econometricians usually try to minimize type 1 error. So you fix the size of type 1 error alpha to a specific level, and that's usually called significance level. Okay, so you fix the probability of type 1 error at 1% and find if the H1 or sorry, find if the H0 is true or not using the regression analysis. Then the significance level of your regression results is 1%. Okay, so if you are more lenient and you want to fix the probability of type 1 error at 5%, then 5% is the significance level. So the lower the significance level, the better. The more precise your testing is. Okay. All right. So let's now try to interpret the results of our regression analysis one by one. So the first hypothesis was about the timing. Okay. So timing of postings is important in this determining the number of likes. That was the first hypothesis, but there's no evidence of that from our regression analysis. So if your coefficient is significant at 1% level, then you should have 3 stars here. If it's significant at 5% level, you should have 2 stars. If it's 10% significant, then you should have 1 star. But there is no stars. That means that sometimes the sign of coefficient is negative, sometimes it's positive, but it's not far enough from 0 because of the dispersion. Okay, that's what the stars mean. Okay, so if you have more stars, that means that it's farther from 0, and you can reject the null hypothesis, and you can say that the specific variable has an impact on dependent variable. But here there's no star. That means that the timing is not important when you control for other variables. So it was not the timing, but other variables that affected number of likes. Okay, so we can say that timing is not significant from this table. And then second is the frequency of posting, and the variable postings last 3 days was significant at 5% level, and it was negative. That means that if you post too frequently, then the number of likes you get might decrease. Okay, and if you use the size of the coefficient to interpret the results, then you can say that if you post photos in 2 consecutive days, then the number of likes you get would lower by 5. So if you post 4 postings in 3 days, then the last posting should have 15 fewer likes than the first posting. That's the way you interpret this result. Okay, and it's 5% significant, so it's quite significant. And in terms of the people who are in the photos, baby was not very significant, and wife was significant, and myself is not significant from the results. Okay, so I thought the baby or having baby in the photos might have negative impact on the number of likes, and the sign is negative, but the problem is there is no star, right? That means that it's not significant enough in 10% level. Okay, but having wife was very important, even after controlling for other factors like special events or something like that. Okay, and having myself was not very important. Okay, that's the way we can interpret the results from the regression analysis. And fourth hypothesis, I thought having a specific hashtags like babystagram was significant in boosting the number of likes that I have, right? And I think it's true that having babystagram or more hashtags in general is important in having or in getting more likes, right? So both are positive and significant. So you can say that having a specific type of hashtags and having more hashtags may be important in getting more likes. Okay, so far I just tested 4 different hypotheses, and I proved some of them and I didn't prove some of them. So that's not very difficult, right? So that's the way we use the numbers here to prove our hypothesis. Adding to that, I can say more about the variables and the number of likes that I get. The first thing is landscape. So I think the landscape was very important. So you see the coefficient on the variable landscape is positive and significant. It actually is very significant at 1% level. That means that having landscape on the photos makes the number of likes that I get go up. Okay, I think it's because most of my friends are in South Korea, and I post the scenic landscape of South Africa on the gram, and people in South Korea like it. And next thing that is noticeable is this. So the subjective evaluation of postings by myself and whether I have special event or not was actually not important, not significant. It doesn't have stars. Okay, that means that no matter what I think about the postings, it doesn't matter. Other things like landscape, having wife, having hashtags are more important. Okay, and whether it's special day or not, it's not important. Okay, the characters that are in the photos is more important than whether it's ceremony or wedding or other things. Okay, that's the conclusion I get. And then r squared. Okay, so here I have r squared is 0.58. That means that around 58% of the variation in y, in the number of likes, can be explained by the variables I have in the model. Okay, and remaining 42% is not explained, so it's in error term. So I can't explain remaining 42%, but I can explain around 60%. Okay. And then I added 2 more columns in the regression result table. Okay. The first one is likes on others. Okay. So I thought people respond to the favor that I did for them. Okay, so if I gave them more likes, then they would give me back responding to the likes that I gave them. Okay, that's the first. The second thing that I tested, and it turns out that it was not the case. Okay, so there is not significant. So people didn't pay back the likes, if you like. Okay, but they just click likes when they think my posting is good enough. Okay, and then the third thing I test is, so it's actually not the third thing, but you remember that I had outlier. I got 90 likes in one posting, and that was the outlier, which might change the general results. So I removed the outlier and did the same test with same variables, and there were several differences that I got from the third model, and that's the effect of babystagram. So now the effect of Bayes diagram is gone. There is no stars on the coefficients of Bayes diagram, right? That means that it's not always work. It does not always work. The having a specific kind of hashtags does not always work, but it works only very seldomly. Okay, so it's outlier. That means that it can't be generalized. Okay, but other things like having wife or the frequency of postings or having landscape are still remaining significant. Okay, so sometimes you might have heard about robustness check, and robustness check is to see if the results that I got from one regression analysis is still robust to changes or different combinations of variables or something like that, or removal of outliers. So if when I remove the outlier here, the significance of Bayes diagram variable is gone. That means that the previous results was not robust. Okay, so you have to do robustness checks as well. And then another change is that now I have a significant subjective evaluation, right? So it was not the hashtags, but subjective evaluation when I removed the outliers that were more important. Okay, so so if you changed some, if you remove or if you include some other variables or some other observation, then the results might be changing. Okay, so you have to be very careful when you interpret the results with outlier and without outlier. Okay, so I think that's it for the result side. All right, now I can make conclusions out of the experiment. Okay, the first hypothesis was not true. The timing of postings doesn't affect the number of likes I get. Okay, and second, frequency does. So I shouldn't post too often. So that's the second conclusion that I got from the experimentation. And but yes, wife matters. I should try to persuade my wife to have her on my Instagram photos, and it's not always easy. My wife doesn't like to be in the photos, but if I want to get more likes, then I have to persuade my wife. And fourth, hashtags sometimes work, but not always work. But the problem is, what's the point of having hashtags and getting more likes? I mean, it's just, I mean, for me, I mean, I don't know if it's true for you, but for me, posting photos on Instagram is to, share the cherishable moments with the friends here in South Africa and in South Korea and in the UK and other places, not to get more likes. Okay, so having hashtags and getting some likes from strangers wouldn't, be very important to me. So it's just, I mean, so these conclusions are to show the usefulness of regression analysis, and I don't care much about the number of likes I get, and I'm not using this result to get more likes. Okay, I mean, but you clearly see that you can use regression analysis and other descriptive statistics to prove the hypothesis you are interested in. And you can apply this in any historical questions, any historical research, if you have some data. Okay, that is the point. And just forget about the Instagram now. Okay. Okay, but forget about the Instagram, but think about other things that you want to test or other things that might be missing in the regression analysis that I just did. Okay, so first thing you can think about is the variables that might be omitted. Okay, so which variables can you test further? So we have r squared of 0.58, 0.6. That means that you still need to explain remaining 40% of the variation in the number of likes. Okay, so which can be included in the model and explain the unexplained bit. Okay, So think about other values, so other variables, and what type of graphs or tables are most suitable to present those variables. I use several tables and several graphs, but you might be able to find more effective ways of presenting these results. And what factors should you consider when interpreting results? So this regression analysis or quantitative skills are not perfect. Okay, sometimes you have omitted some variables, and sometimes you misinterpreted the results. Sometimes you are confused of the correlation and causation, and sometimes you measure the wrong variable. Okay, so if we can think about so many things that might have affected the interpretation and something that led to false conclusion. Okay, so this is actually what I did this in a group, but it's not possible at the moment. So just think about it on your own, and if you have any good ideas or if you have something that is not clear, just email me. Okay. But something that is commonly mistaken is the relationship between correlation and causation. So correlation is statistical measure of the association between two variables. If two variables move along the same direction, then these two variables have a correlation. Okay. So there is this formula that you can calculate the correlation, and if R here the correlation is bigger than 0, that it means that they move in the same direction. If R is smaller than 0, then they move in the opposite direction. If R is close to 0, that means that they have no correlation. Okay. The common mistake is to confuse between correlation and causation. Okay, but we talked about correlation so far, but what we are actually interested is not correlation but causation. Okay, so the two variables that are related doesn't say much, but if one variable caused another thing, then it's more interesting. So if you want to talk about the factors that might increase the economic growth of your country, then it should be causation, not just correlation. For example, think about the relationship between ice cream sales and temperature. Okay, so ice cream sales and temperature tend to go up at the same time. So if you have higher temperature, if it's getting hotter, that the ice cream sales must be increasing as well, right? But you can't say that ice cream sales cause global warming, right? Even though these two variables have correlation, the causation goes not from ice cream sales to temperature, but the other way around. So it's the temperature that caused the increase in ice cream sales. So you shouldn't, make it reverse. Okay. So the relationship between ice cream sales and temperature is obvious, but it's not always as obvious as like this. Okay. So if you think about the relationship between institutions and economic growth, so we tend to think that the quality of institutions is important in determining the size of economic growth, size of economic development. So if you have good private property right protection, then you might have higher economic growth. That's what we think. And if you have good democracy, then your economic growth might be bigger, something like that. But it might not be the case. So it might be the economic growth that made you have better institutions. So making or having good institutions is usually costly, so you need money to finance it. So the causation might be in the different direction, opposite direction. Okay. And also, if you think about immigration and conflict, this is actually the topic of my research. And if you have more immigrants in the population, the population of your country, then it can lead to more conflict, because the ethnic composition or racial composition might be getting more heterogeneous, and there might be more tension or something. So it's gonna make conflict more frequent. But the other way around might be the case. Like if you have more conflict in your country, and then it would make immigrants leave, or it would make the racial composition change or something like that, right? So the relationship between immigration and conflict might have a correlation, but it might not be the causation, or causation in the opposite direction or something like that. So distinction between correlation and causation is very important when you interpret the results from the quantitative analysis. So in order to fix this causation problem, reverse causation problem, or force correlation problem, we usually use instrument variable. Okay, and this reverse causation is sometimes called endogeneity problem. I mean, the terms are not very important at this stage, but just to remember that there is instrumental variable approach to fix reverse causation problem. Okay, that's the most important one. Okay, so econometrically, instrument variable can fix the reverse causation problem, and if you have a good instrumental variable that is strongly correlated with the explanatory variable, but now with dependent variable, then you can take out endogenous component out of the experimental variables, and then you can say that the results from your regression analysis is causal, not just correlation. Okay, just remember the term instrumental variable. That's what I want you to do at this stage. Okay. Okay, this is an example from AJR that I mentioned before. If you are interested in, just ask me. I can send you the paper. All right. So correlation and causation are different. Okay, that's, if you remember one thing from this lecture, then it should be this. Okay, correlation and causation are different. And lastly, I think I've got several more minutes. So lastly, I'm gonna just briefly explain what GIS technique is. And it's not gonna be as theoretical as I did before for descriptive statistics and regression analysis. It's just the application of GIS, geographic information software or geographic information system, in practice. Okay. So this is basically using maps. You can use maps to effectively visualize your research outcomes. So you can use tables, of course, you can use graphs, but sometimes maps are more effective, especially when your research outcomes have geographic elements. Okay, I use ArcMap, but this it's actually costly. It's not free. So you might want to use QGIS, which is open source. Okay, so and actually I think the functions are vastly similar between these two software packages. So you can use QGIS if you want to have maps, but it's not just having maps. It's to express some information on the maps. Okay. Something like this. I made this poster when I was doing PhD, and there are two maps at the bottom of this poster, right? So the first map is to show the rate of net migration among the Soviet Union or Soviet territory in 1980s, before the collapse of the Soviet Union. And then the right map to the right is expressing the rate of net migration after the collapse. So I show the changing patterns of migration from before collapse and after collapse. So I kind of show these changes in the maps. And then this poster is obviously getting was obviously getting good feedback. So having maps is sometimes very effective in showing the intention of your research. Okay. So if you want to GIS in your research project, then you would have to know the most important elements of GIS here. Okay. The first thing is shapefiles. So it's a vector map. That means that it has some information in the file, and you can add the information from your research into this vector map. Okay. So if you want to use maps in your research, you should find the shapefiles that are related to your research first. Okay. So for example, if you want to add number of immigrants in a number of residents in Cape Town suburb, then you have to find the shapefiles that have suburban boundaries in Cape Town. Okay. And the second thing is base map. This is raster image. That means that it doesn't have any. You can't add your information into this image, but it has geographic information. That means that it has locational information. So you can match the base map with the shapefiles, since these two images or two maps have the same geographic or locational information. Okay. And then the third thing is projection. So this is geographic coordinate system. So this, for example, the shapefile, two shapefiles, or the shapefile and the base map should have the same projection if these two are to be matched perfectly. Okay. And then the last one is attributable or attribute table in shapefile. So this is something that looks like Excel sheet, and you can put your data in the attribute table using field ID. So the shapefiles usually have an attribute table, and it has FID field ID in different polygons or different lines or different points, and you can match the information data. You can match the data you have with these geographic information in the shapefiles using FID, and you can express your data using different categorization and different colors or shapes or something like that. Okay, I will give you the example of this now. So this is the attribute table of the shapefile that I have. So in the second column, there are different suburbs of Cape Town, and I have the number of couples in 1910s, 1920s, and 1930s, and something like that. Okay, and I can draw I can express these the number of couples in specific suburb in maps using FID to the leftist. Okay. So this is the base map. This is the raster image, and actually this is provided by I think Google Maps, okay? And you can use the map in QGIS or ArcGIS, and on the base map here, I can add the shapefile. So this is the shapefile of the suburban boundaries of Cape Town. So I added the shapefile here, and then I entered the data that I have into the attribute table as I showed you before, and I expressed it in the map. Okay, so I think this is the number of residents or number of couples from Anglican marriage records, and I expressed the population by suburbs using this map. And then I added another shapefile of bigger boundary. So I divided Cape Town into 4 different suburbs: northern suburbs, southern suburbs, and Cape Flats and eastern suburbs. And then I added, so you can add as many layers as you want in the shape if you have the shapefiles, okay, onto the base map. And if you want, you can just remove the boundaries and then leave the number of residents here. And you can use different shapes or different colors just as you want, okay? So okay, so I think I can just now skip this, okay? All right, so there are several useful websites that you might want to get sources from. So the first thing is ArcGIS Online, so you can follow the link here, and New York University Spatial Data Repository and Cape Town Open Data Portal. So I think most of your research would be related to Cape Town, and the last link, Cape Town Open Data Portal, should be very useful. So this has this is ample geographic analysis sources here, so you can refer to this site if you want to use maps. Okay, that's it. Thanks for listening, and if you have anything that is not clear from the lecture today, then just email me. I will try to answer it as soon as possible and as detailed as possible. Okay? Okay, so good luck. Thank you.